Greetings and welcome, friends. Mr. Waddy and my fellow geometricians are here. This is amazing. Actually, internet friends, this is the first time I've recorded a video with these people. They're kind of strangers to me, so I feel a little bit uncomfortable around them. I hope I don't do anything embarrassing with the math. So here's question 4 from last night's homework. We were talking about postulates, which you're supposed to just believe without any proof. And here's like some sort of pictographic postulate. It says, state the postulate illustrated by the diagram. So it looks like it's saying if there's a plane, then there are 3 points on the plane. Is that the... No. Is that the... Yeah, I think that's the plane point postulate by the looks of it. It says a plane contains at least 3 non-collinear points, which is definitely... I already forget what it was called. The plane point postulate. Bam. Yeah, so they're not saying anything with too much confidence or boldness, Rob. I think you agree. 3 points. Yeah, that's kind of all they're claiming. Let's see. Oh, here we go. So using the 3-point postulate, postulate 2.4, which that numerical name for it will only be significant within this course in this textbook. So if you're doing your math on the street and you're like, postulate 2.4, no one will know what you mean. Okay, just so you're aware. That's a Big Ideas exclusive. Here we go. So 3-point postulate using this diagram. What is the 3-point postulate? Broccoli Rob will help us out here. It says through any 3 non-collinear points there exists exactly 1 plane. So, let's see. Well, I have seen on Facebook, I don't know, you guys aren't teachers, so maybe you don't get the same advertisements, where there's like a little like Nerf ball that you can like toss around the room, but it's got a microphone built within it that's like got Bluetooth sync to the computer, so then the students can like whisper into the microphone what the answer is. And then they toss it to the next person, but that sounds a little weird. So guys, look at this. I need 3 non-collinear points. So I could use those 3 or these 3, or looks like H does exist as an intersection there. They didn't put a little dot there, but nonetheless. So I could say H, K, and L form a plane, or something like that. And in this case, that plane has a name M, but I also could have called it plane HKL or LHK or whichever other 3 points that were non-collinear. Basically, the only ones I couldn't use were J, H, and K because those were collinear. All right, how about 8? The plane line postulate. Let's see, plane line postulates. If 2 points line a plane, then the line containing them lies in the plane. So, according to that postulate, I could say that line JK is on plane M. Yeah? Yeah, I think so. I saw that some of us got these ones wrong, which is why I selected them. And now our internet friends will forever enjoy this help. I'm going to skip 10. I think we did pretty good on 10. And I've got another video that goes over that one anyway. Here's 14, though. Points K, L, M, and N are coplanar. Use the diagram to determine whether or not you can assume the statement. So in the diagram, I'll swap colors here. So K, L, M, and N, those are on a line. That's on a line between... Yeah. That looks like that's all on plane X. So I'm going to say true. They're on plane X together. Right? You guys agree those all look like they exist on this plane? Internet friends, that's consensus, just so you're aware. Everyone agrees that Waddy Math is correct about this problem. Everyone. So 16. MN and RP intersect. So let's see. So here's the MN. And here's the RP. Ooh, what did you guys think about this? I'm going to say false. And now you might be like, but Mr. Waddy, right there, I see it. but the problem is that it's like behind the other one. You can see that the two planes that they're on intersect at JL, and they pass through different points at the intersection of those planes. And so, yeah, so they never exist together. They would have had to pass through the same point on that plane. So the answer is no, they don't intersect. So those would be skew lines, S-K-E-W. That's pretty skew. No, I don't think so. No, I'm embarrassed about that. 23, poor life choice. Here we go. All right, select all the statements about the diagram. So, when I looked at this, a lot of us got this partially wrong, but maybe had parts of it right. So let's see, ABC coplanar. As long as they're not collinear, that's got to be true. And I'm looking at the ones that I cannot conclude. But here, A, B, C, yeah. Plane T intersects plane S in BC. So T and S and BC, Boston College, right there. So that's true. AB intersects CD. So here's AB, there's CD. Those look skew, so I'm going to say that's false. So that's the one of the first things I could shade in right there. Look at that. HFD are coplanar. H, F, D. What are your thoughts? No? Broccoli Rob looks like way into whatever he's doing. You don't need headphones for this part. I'm not live streaming it. Although it would be pretty cool if you were watching and live tweeting this live Wadi Math presentation. So even though they're not on one of the drawn planes, the fact that they're non-coplanar, you could imagine like a diagonal plane that passes through them, right? H, D, and F. Yeah. So I'm going to say true. Really? Oh man, let me check what the big idea says. So this was question 23. All right, class. We've got a controversy here. According to this. Yeah, the big ideas did check that box. Uh-oh. Well, the only way they wouldn't be... Well, it's something that I supposedly cannot conclude. So they're saying they checked it, claiming that it would not be true. I'm gonna... No. But I don't know. What are your thoughts? Yeah.
Well, I think that they were just referring to the two.
Maybe. But I would argue that through any three non-collinear points, there exists exactly one plane. So I'm going to put it in the category of true. I'm going to disagree with big ideas here. I'm taking a stand. Feel free to comment below what your thoughts are about these planes. So let's see. Plane T is perpendicular. That's what that upside down T symbol means to plane S. T, S, perpendicular. Notice this right here is trying to indicate that, yeah, those planes are perpendicular to one another. So yeah, that sounds true. That sounds true. I believe it. Point B bisects HC. No go. I don't know that. I do not know that. All right, point B, H, C, unless it was labeled somehow that those were two congruent segments, or if I had a fact somewhere that said B is the midpoint of HC, I can't conclude that. Let's see, ABH and HBF are a linear pair. ABH and HBF. I'm going to say that's true. Man, that was a pretty good sneeze. I tried to accentuate the end there just a little bit. Feel free to grab that sound clip off this video, use it as your ringtone, or in any dubstep song that you edit in the future. Let's see, AF and CD are perpendicular to each other, so AF and CD, I'm going to say no. I don't even think they intersect. Right? Yeah, I'm saying no. So there, that's where I commit. Controversial one is point D, but I think it was just probably a mistake of the textbook. All right, thanks for watching, Internet friends. Bye-bye. Feel free to add your channel in the comments below. Some recommended, if you like Wadi Math, you may also like fill in the blank.